Hello everyone, this video is about the steady state characteristics and transfer characteristics of power transistors. So what is meant by the steady state characteristics? So the output characteristics and the input characteristics of the power transistors are nothing but the steady state characteristics of the device. So if you observe the circuit here, the circuit is in the common emitter configuration. Even though we have three possible configurations such as common collector, common base and common emitter, the common emitter configuration is the one which is widely used for switching applications. So that means the base is the input, collector is the output and emitter is the common terminal. So by looking into this diagram, if we apply KVL to the input side, we have VB minus IB RB minus VBE equal to 0, and if we apply KVL to the output side, we have VCC minus ICRC minus VCE equal to 0. IB is the input current, IC is the output current, VCE is the output voltage. So if there is no voltage applied to the device, that means if IB is equal to 0, we know that IC is also equal to 0. So if IC is equal to 0, then what will be the output voltage VCE? The output voltage VCE will be equal to VCC. Then as you go on applying the input voltage, the base current will increase. If base current increases, then what happens to the collector current? Collector current also increases. How? We know that collector current is beta times the base current. So if the base current increases, the collector current will obviously increase. So now when this increases, what will happen to the output voltage? Output voltage which is equal to VCC minus ICRC. So as IC increases, this VC is going to drop. So initially when the circuit is off, the output voltage will be maximum, and when the circuit is conducting, or then the voltage will reduce and finally attain the saturation value. Since our transistor, say if we take an NPN transistor, this is a collector, base and emitter, this PN junction is like a diode. We have the input characteristics, that is input current IB versus the voltage VBE. The characteristics is same as that of the diode. So transistor input characteristics is same as that of the diode characteristics. Whereas the output characteristics, which is a plot of output current IC versus output voltage VCE, you can see that if the base current is 0, then the device's collector current is also equal to almost 0, but practically you will have small leakage current. In that case, the device is said to be operated in cutoff region. As you go on increase the base current, what will happen to the collector current? It is going to increase. So initial part of this curve, you can observe that this part of the curve, you can observe that VC is almost very less. So around 0 to 0.4 or 0.5, something of that kind. So this is the voltage reached when your device has started to conduct. I have told you, as the circuit or your device has started to conduct, the output voltage drops. So it drops to a very low value, but it never reaches 0. This is nothing but the saturation region. And when Vc is increasing but your IC remaining constant, if your IC remaining constant, then it is the saturation, it is active region. So we have three regions of operation. One is cutoff, the other one is saturation, and third one is active. So most of the power converters, we operate transistor as a switch. That means either it is operated in cutoff region or it is operated in the saturation region. It is not operated in active region. In active region, the transistor operates as an amplifier. So if you observe here, initially when IB is 0, the voltage is maximum at VCC. That means it is operating in cutoff, and then as the device conducts, the base current increases, the VCE is going to reduce and it finally drops down to a low value which is equal to the saturation voltage. So this is the transfer characteristics. Now let us obtain the current relationships of a power transistors. So we know that the emitter current is equal to the sum of the collector current plus the base current. The current gain, DC current gain, which is beta, is nothing but IC by IB, and we know that current gain alpha is the ratio of collector current to the emitter current. So your IC actually is approximately equal to the emitter current IE. So if we divide this equation by IC, we get IE by IC is equal to 1 plus IB by IC. So we can write this as 1 by alpha is equal to 1 plus 1 by beta, or we can write 1 by alpha is equal to beta plus 1 by beta, or alpha is equal to beta divided by 1 plus beta. The same way, if we rearrange, we can write beta as alpha divided by 1 minus alpha. So the collector current can be expressed in terms of base current as beta IB, and alpha and beta constants can be expressed in this way. So in the next video we will see how the transistor operates as a switch.